Thank you. Yes, give me a moment. I'll share the PPT.
हाँ। अच्छा मारो अभी चला होगा ना 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 टॉप में ना अपना अभी एचएमआर कितना चला सुबह में क्या था ओपनिंग क्या था क्लोजिंग क्या है
Madam, can you please give me the host access again?
रिक्वायरमेंट हाँ हो सही बानू गड़बड़ है जाओ ना फ्रेश हो क्या है फ्रेश हो क्या उसके फ्रेश क्या है
Guys, can you please mute yourself, Tiwari, Aditya Kumar Tiwari? Yes. So we are discussing about the chemical safety. We have seen why we need to follow the safety precautions with the handling of chemicals. And we have seen what are the 10 principles we have to follow setting up in the chemical industry, and what is the necessity of chemicals in our day-to-day life. And also we have seen what are the different types of hazards associated with the chemicals. Okay. Today we will see what are those types of chemicals. So these are the UN classification of chemicals. United Nations, they have defined all the chemicals into these 9 categories. So there are lakhs of chemicals, as we have discussed yesterday, thousands of chemicals we have discussed yesterday. But it is not easy to remember all the chemicals classification, or it is to understand the characteristics of the chemical. So they are categorized into this: explosives, gases, flammable liquids, flammable solids, oxidizers, poison, infectious substances or biological substances, radioactive, corrosive, and miscellaneous. So if you see any chemical, definitely it will fall under either of these 9 chemicals. Okay. Now we'll understand the interpretation of MSDS. We'll talk more about each chemical in the following classes. As I mentioned yesterday, we will see in detail about MSDS. So now we'll try to understand what are the contents will be there in the MSDS. So if at all you want to understand about any chemical, it is very much necessary to know about the MSDS. Like for us, we have a resume or CV. So when we see the resume, I can understand the complete qualification of the people, complete qualification of the person, detailed educational qualification, skills or certifications, address, phone number, email ID, everything. Similar way, MSDS will have the complete biodata of the chemical. So there are few the keywords which are there in MSDS. So MSDS లో ఏంటి మనకి అన్ని రకాలైన కెమికల్ కి సంబంధించిన డీటెయిల్స్ అన్ని తెలుస్తూ ఉంటాయి. సో ఈ స్క్రీన్ లో చూసినట్టుగా మనకి ఇవన్నీ కూడా కెమికల్స్ ని వివిధ రకాలుగా విభజించారు. అందులో పేలేవి, ఘన పదార్థంలో ఉండేవి, లిక్విడ్ రూపంలో ఉండేవి, సాలిడ్ రూపంలో ఉండేవి. ఆక్సిడైజర్ అంటే మీకు చెప్పాను. ఆక్సిడైజర్ మీన్స్ వాట్? సో whenever it interacts with the chemicals, it will produce, it will generate the oxygen. The poisonous, radioactive, corrosive, and miscellaneous. Miscellaneous will be a multiple categories which will fall under it. ఈ 8 కేటగిరీలో కవర్ అవనివి miscellaneous కింద వస్తుంటాయి. Okay, first we'll see the CAS number, CAS number. It is a unique number for the different chemicals. What does it mean by unique number? For example, if you say a 10th class hall ticket number, that is the unique number for every individual. No number will be similar. It will match with the others candidature. అంటే ఒక 10th క్లాస్ స్టూడెంట్ నెంబర్, హాల్ టికెట్ నెంబర్ ఏదైతే ఉంటుందో అది వచ్చేసి యూనిక్ నెంబర్. స్టేట్ మొత్తం, కంట్రీ మొత్తం మీద అదొక యూనిక్ నంబర్. సిమిలర్ వే ఫర్ ఈచ్ కెమికల్ they have a unique numbers, which is chemical abstract service number. To provide a single unique identifier with the naming the chemical, the CAS for the acetic acid, which is, we see in acetic acid, the number given as 64-19-7. The CAS is called as chemical abstract service number. Here it will not give any hazard of the chemical. అంటే దీని ద్వారా మనము కెమికల్ యొక్క ప్రమాదకరమైన నేచర్ ను మనం కనిపెట్టలేము. అంటే ఎటువంటి హానికరమైందా లేదంటే దీని యొక్క నేచర్ అంటే కనిపెట్టలేము. బట్ ఫర్ ఐడెంటిఫికేషన్ we can use this CAS number. Then UN number, which is United Nations, a 4-digit number. It is assigned for the potentially hazardous chemicals. So ఈ నంబర్ ని మనము hazardous chemicals ni identify cheyadaniki use cheyastu. For example, ammonia UN 1005 and corrosive liquids UN 1760. So this is the numbers which can be used for identification of hazardous chemicals. Then HCAM, which is EAC, hazardous chemicals code, or emergency action code, is an emergency action code confirmed by the Health and Safety Executive UK. It consists of number 1 to number 4, followed by 1 or 2 letters, and signifies the type of fire extinguisher required, of personal protective equipment required, whether the spillage should be contained or diluted with water, whether the material is reactive, or whether the evacuation of the surroundings are necessary. So what it will have? It will have a consists of 1 to 4 numbers and 2 alphabets. అంటే ఏంటి, 1 నుంచి 4 లోపు ఒక నంబరు, దాని తర్వాత 2 ఆల్ఫాబెట్ లెటర్స్ అనేవి ఉంటాయి. సో దీని ద్వారా మనకి ఏం తెలుస్తుంది? ఒకటి, ఎటువంటి ఫైర్ ఎక్స్టింగ్విషర్ యూజ్ చేయాలి. 2, ఎటువంటి పీపీఎస్ యూజ్ చేయాలి. 3, దీన్ని వాటర్ తో డైల్యూట్ చేయొచ్చా, కంటైన్ చేయొచ్చా. 4, ఇదే రియాక్టివ్ మెటీరియల్, నాన్ రియాక్టివ్ మెటీరియల్. తర్వాత ఎవాక్యువేషన్ చేయాలా వద్దా, వెదర్ ఇట్ ఈస్ ఎవాక్యువేషన్ ఇస్ necessary or not. If you see a sodium cyanide, which is 4x, and then the vinyl chloride, it is 2We. So like this, they should give the unique SCAM number or EAC numbers. And there is other abbreviation you should know, which is ADR, agreement concerning carriage of dangerous goods by road. So these numbers will be given for the various types of goods which are hazardous in nature. I can say chemicals. They will give this ADR number. It is for the road transportation. This European agreement was arrived at the Geneva by 19 European countries for the safety of the international transport by road. It deals with the classification of hazardous substances, their packaging, loading, and also unloading, transportation, and equipment. So it deals with not only with the transportation, it also deals about the packaging, how you are packing the chemical or the containers, then loading and unloading, transportation, and its equipment. It gives hazard identification number like UN hazard number and a comparison as below. So how it will be? For example, if you say a UN number, which is explosive, and emission of gas due to, that is no comparison for number 1. And if you see gases, compressed gases, liquefied or dissolved under pressure or deeply refrigerated, here it will be emission of gas due to pressure or due to chemical reaction. So that is the classification difference. So UN number I mentioned, United Nations number. ADR will be agreement concerning carriage of dangerous goods. So that is the difference. Here they will say gases compressed. Here they will say emission of gases due to pressure or due to chemical reaction. Then flammable liquids, flammability of liquids, vapors under gases, and flammable solids. Here will be flammability of gases, oxidizing substances or organic peroxides, oxidizing or ineffect, poisonous, which is toxic or infectious substances, toxicity, radioactive substances, we can say, and corrosive substances, they will here be called as corrosivity, and miscellaneous or dangerous substances, risk of spontaneous violent reaction. So this is the how they will categorize, they will classify the chemical. Now we'll see what is the appearance, state, and order. Appearance includes what it means, how it looks. And chemical and and we usually used to see our appearance, how you are looking, how is based on your pressure or the things which you have worn on your physically and all. So we see appearance. Appearance include the state means physical. Appearance include the color. State means the physical state, which is solid, liquid, or gases. And order indicates the smell. What kind of smell which is giving. The order threshold is minimum of level, which is ppm, parts per million, where the order will start, and if the order threshold is lower, Then the permissible safe limit, example TLP, threshold limit value, or STEL, short term exposure limit, and also IDLH, immediate danger to life and health. Then LC. This we have discussed today. LC means lethal concentration. Concentration means the chemical is mixed in the atmosphere, like it is mixed in the air. The order indicates the presence of gas and some safety margin is available in the runaway to take the necessary precautionary steps. But if it is higher, the gas becomes toxic and hazardous before its order starts, and also this condition is risky. In that event, a reliable gas detector is useful. Sometimes order is added to you to detect the gas leakage. Example, addition of mercaptan in the domestic LPG. So to understand the leakage, mercaptan can be used for the detection, and the ability to detect order may vary from person to person and may be mislead if the other odorous chemicals are simultaneously in present. So basically, the order can be detected from the various ways, and some of the chemicals, even chlorine also, if I'm not wrong, in the we use the hypo solution for the detection. Whenever the chlorine is leaking, if you put the hypo solution nearby, it will give the white color fumes. In a similar way, so sometimes it is difficult to identify, or sometimes the mix of solvent in other chemicals also may have the leakage. Then specific gravity. So it is very important to understand what is mean by specific gravity. As a base standard, water specific gravity is equal to 1. So now we'll see what exactly a specific gravity is. So it is the ratio of the density of a material to the density of water. అంటే ఇది ఆ వస్తువు అంటే ఆ మెటీరియల్ యొక్క బరువుని, డెన్సిటీ అంటే బరువు లేదంటే సాంద్రత బరువు అంటాము. ఆ బరువుని 1 లీటర్ వాటర్ తో కంపేర్ చేయడం. ఫర్ ఎగ్జాంపుల్ 1 లీటర్ వాటర్ 1 కేజీ బరువు అనుకోండి. ఆ కెమికల్ 1 లీటర్ తీసుకుంటే ఎంత బరువు వస్తుంది? సో అది మల్టిపుల్ ఫ్యాక్టర్స్ విల్ డిఫర్ బేస్డ్ ఆన్ ద విస్కాసిటీ ఇట్ విల్ డిఫర్. సో ఇక్కడ చూస్తే lighter material which is less than 1, example benzene which is 0.88 will float, and also heavier materials which is greater than 1, which is sulfuric acid, which is 1.84 will sink. So there is a 2 materials we have taken example. అంటే ఇది ఏంటంటే వాటర్ కంటే ఈ మెటీరియల్ అనేది బరువు ఉంటుందా ఉండదా అని. ఇది ఎందుకు ఉపయోగపడుతుంది అంటే, as I mentioned in the bottom, this information is useful for spill or fire control. One is, if it is lighter than water, it will be floating on the water. If it is heavier than water, it will sink in the water. So based on the specific gravity, we'll try to do the spill management as well as fire control, which means nothing but firefighting arrangements. Then vapor density. So there it is specific gravity, which is talking about the weight of the material. Vapor density, it is talking about the weight of the vapor which is released or which is generated by the chemical. In the specific gravity, we will compare with the water, and vapor density we will compare with the air. So air, if we consider, it is equal to 1, the density of the air. It is the vapor weight per unit volume. Unit volume of chemical in a teaspoon, 1 cubic meter or 2 cubic meter or 10 cubic meter. ఆ యొక్క డెన్సిటీ అనేది ఎంత ఉంటుంది? So in MSTS, it is gives as the ratio of the density of the gas or vapor to the density of the air. So if I take 1 cubic meter of air, which is equivalent to 1, And same way, if I take 1 cubic meter of, 1 second, guys, just to give a minute. Yeah, sorry. So we'll compare with the same amount of volume of the chemical vapor, which is equivalent. So the air density is 1.293 grams per liter. But here it is the considered as 1 for the easy comparison of the gases. So if you see a lighter, which is less than 1, like ammonia, which is 0.59, will go up, which means whenever ammonia leaks, what will happen? It will try to go away in the air, and also heavier than means which is vapor density above 1. That is chlorine, which is 2.49, will become down on the bottom. If you see here comparing with the air vapor density and the chlorine vapor density, which is almost 1.49 times, which is heavier or higher than the air. So that what will happen? It can't go higher side. It can't go, it can't rise. So what it will do, because of the weight is higher, it's always trying to settle on the ground or any pits or any potholes. There it is trying to settle. So basically, this information is for the creation of ventilation purposes, and also emergency evacuation purpose. So why ventilation is required? So I'll take an example of chlorine. So first explain Telugu. So ఈ వేపర్ డెన్సిటీ అనేది మనకి గాలితో పాటు కంపేర్ చేసినప్పుడు ఈ కెమికల్ యొక్క కండిషన్ ఏంటంటే గాలి కంటే బరువు తక్కువ ఉందా ఎక్కువ ఉందా? తక్కువ ఉంటే ఏమవుతుంది? గాలిలోకి పైకి వెళ్ళిపోతూ ఉంటుంది. ఎక్కువ ఉంటే ఏమవుతుంది? పైకి వెళ్లకుండా కింద ఫ్లోర్ లెవెల్లోనే ఎక్కడున్న గుంతలలో వాటిలలో వీటిలలో అది సెటిల్ అవుతూ ట్రై చేస్తూ ఉంటుంది. సో బేసికలీ ఇది మనం ఎందుకు యూజ్ చేస్తామంటే ఫర్ ది, please repeat again. Okay, fine. I'll explain Chandramati. Yeah, Chandramati. Yeah. Basically, this vapor density is will compare with the vapor density of the air. If you see the vapor density of air, 1 liter of air, which is equal to 1.293 grams. So for the easy comparison, we'll always used to have compare with the number 1. So whenever you see a vapor density in your MSDS, so if it is say it is above 1, so you should train your people. Those chemical, if any vapor generates, it will always on the floor level, so that what will happen? You can escape in a standing position. So if you say ammonia, which is less than, it will go heavier, and which means which will rise. It will not be there on the floor level. There, in case of any leakage happens, to evacuate the people, they can crawl and they will come out of the building. We say it is a chlorine because of heavier than air. It will always trying to be in the close to the ground level because of heavy. It can't go rise. So in such case, what will happen? The people should not crawl. They can stand and they can walk out immediately by using any emergency PPEs. That is the difference. Based on if it is above 1, greater than 1, we will do proper ventilation in the floor level. If it is above 1, we try to put the ventilation or exhaust on the higher levels, so that because of it is lighter than air, it will always have tendency to rise up. Clear, Chandramati? Any questions or still any clarification? Yeah. Okay. We'll try to see one example also, so that you can understand better. Okay, emergency evacuation. So as I take an example, ventilation basically what will happen, I take an example of chlorine. So if you see a chlorine storage area, basically they will have the exhaust suction, which is very close to the floor level because it is heavier. And even if you see any LPG storage areas, LPG also, which is heavier than air, it will not rise up if you go on the negative heights or pits or any such. So for the LPG storage area also, there they will put the ventilation on the bottom, or they will provide some openings in the bottom so that it will get diluted. Okay. Then boiling point is also very important. Maybe these are the some of the definitions you may get in the examination also. Sometimes 1, 2 definitions they'll ask you as a 3 marks questions. Okay. Boiling point. It is. I think everybody knows this boiling point. What it is exactly. So it is that the temperature at which the material changes from a liquid to a gas, and below this point, the liquid can evaporate to form a vapor. But at the boiling point, changes from liquid to vapor is faster. So boiling point means it is a temperature at which the liquid to gas. అంటే ఒక కెమికల్ కి బాయిలింగ్ పాయింట్ అనేది మీ MSDS లో 20 degrees అని ఇస్తే వన్స్ ఆ కెమికల్ అనేది 20 degrees టెంపరేచర్ కినక ఎక్స్పోజ్ అయితే అంటే 20 degrees కినక మరిగించబడితే అక్కడ నుంచి అది గ్యాస్ లోకి మారుతూ ఉంటుంది. ఫర్ ఎగ్జాంపుల్ వాటర్ బాయిలింగ్ పాయింట్ ఇస్ 100 degrees. Whenever the water reaches 100 degrees centigrade, what will happen? The water starts evaporation. Okay. Whenever the boiling point, it crosses the boiling point. So the conversion ratio or the conversion speed will increase. This increases the vapor concentration of its pressure, and this condition is causes high risk of fire and also explosion or toxicity. So it is risky than a liquid state. So because it is spread a larger area, a larger volume. Then melting point. It is simple. Melting point is nothing but like an ice. So whenever the melting point, it is a temperature at which solid material melts and also become a liquid. This information is useful for the storage and also handling purposes. A melted material may resort a container also. Because maybe in the solid state, takes the less volume. Then it has become a liquid, it takes the more volume. Okay. Melting point means solid to liquid. Then freezing point, it is a temperature at which a liquid material freezes, also becomes solid. This information is useful for storage and handling purpose. And a frozen material may burst a container. This is also one of the critical temperature at which a material is to be handled or need a storage condition. In that also they will mention, do not store or do not expose to the direct sunlight. If you see in our any toothpaste or any other kind of the gels or the balm you use for the painkillers or any other what do you call it, gel or balm, they will mention do not expose to the direct sunlight. Even some of the medicines also, medicines also, they used to mention do not expose to the direct sunlight or keep away from the children. Similar way, every chemical have its own comfortable zone. So comfortable zone in the sense at what circumstances it will be behave in a safer manner. So that is the comfort zone or the conditions we can say, storage conditions. Then vapor pressure, it is the pressure in, we can call it in mm or Hg upon the atmosphere of the vapor of the material at the fixed temperature 20 degrees. Higher vapor pressure indicates higher concentration, therefore higher hazard due to fire or inhalation. Vapor pressure means it is the concentration of the chemical. We will see at 20 degrees. At 20 degrees, what will be the concentration of the specific chemical. If the vapor pressure is more, which is higher hazard. Then solubility, it is the ability of the material to dissolve in water or other liquid, which is also solvent. It may be expressed as a ratio or described by the words like insoluble, very soluble, springly soluble, or missolvable. Missolvable means solubility means kariginchukuneda. So for example, if I mix water and sugar, so I'll take a 1 glass of water, I'll put 1 spoon of sugar, then I'll stir it. It will dissolve or it is soluble in water. So I keep on adding the sugar to that glass of water. When it reaches to the certain limit, the water will not take any extra sugar. The sugar will not get dissolved in water. That is the solubility. Insoluble means, for example, kerosene. If I put a sugar in kerosene, it will not solve or it will not dilute in that. Okay, that is the solubility. Whether this material is a soluble material or insoluble material. అంటే కరిగిపోవడం అంటే దానిలో కరిగిపోతుంది లేదా కలిసిపోతుందా లేదా అన్నది ఇక్కడ మనం తెచ్చుకోవచ్చు. This information is useful to decide a scrubbing media, spill control, or any firefighting material, and also the procedure. Such solvent should not be hazardous. So, ఎందుకు వాడతాం ఈ solubility-ని? Scrubbing media. Scrubbing media means what? Scrubber means in the process, in case of any chemicals gets escaped or which is leakage happens, those vapors are connected with the scrubbers, which are acting as the diluting equipments to reduce the concentration of the chemicals before it is releasing to the atmosphere. What they will do is there they use the diluting material for the chemical. So this vapor will be go through the scrubbers. There the dilution material will be there. It will be sprinkled on that, so that the concentration of the vapor or the leakage, the leaked glass will get diluted. Okay. Then pH. pH means what? The hydrogen ions in a given liquid, or the number of hydrogen molecules in a given liquid. It is a measure of acidity or alkalinity of a material when dissolved in water. It will be expressed in a scale of 0 to 14. So pH can be shown as 0 to 14. If it is in towards 0, it is more acidic in nature. అంటే అది యొక్క యాసిడ్ రూపంలో ఉన్నట్టుగా మనం చెప్పొచ్చు. If we say pH is 1, it is highly acidic. అంటే దాని యొక్క యాసిడ్ నేచర్ అనేది ఎక్కువ. pH 14, highly base. Okay, you see here 0 to 2, which is will be called as strong acidic, and 0 to 5 weak acidic, and 6 to 8 is neutral, and 9 to 11 is weak basic, and 12 to 14 is strong base. Okay. Now we'll see a flash point, which is also very important. A flash point, it is the lowest temperature at which a material gives off enough vapor near its surface to form a flammable air vapor or gas mixture, so that it can be ignited if a spark is available. The lower the flash point indicates, higher the hazard, as it can cause fire at a lower temperature. It is expressed as a closed cup, which is CC, or open cup OC. The CC value is slightly lesser than OC. So flash point means was the lowest temperature at which a chemical gives enough vapor. What does mean by lowest temperature? And if I say a chemical with a flash point of 23 degrees, which means 23 degrees is the lowest temperature. Where it will give the enough vapors to produce or to ignite the fire. So it is a mixture. Whenever the spark is available, it will get ignited. The lower flash point indicates higher the hazards, which means lower flash point means the number. For example, one chemical, I will say the flash point is 10 degrees. Other chemical, I will say the flash point is 20 degrees. Whenever the flash point